All right. Whenever you're ready, press go live.
Okay, I'm gonna press it in 1, 2, 3.
Good.
And we're live.
Hello, everyone, and welcome to this episode of the YoungWonks podcast. Today, we are talking about some tips for 3D printing, making your 3D prints go well. But first of all, we've actually got a question before the podcast even starts. That's nice. Can you 3D print stuff like pizza? And also, there's totally unrelated, how much skill will be required to create a teleportation device? How long do you think it'll be until someone builds one? And what material would you use? Can you 3D print stuff like pizza? You can 3D print food using suitable materials. I saw a chocolate 3D printer at a maker fair once. Pizza's a little bit complicated because you have to bake it.
Mm-hmm.
I do not recommend putting string cheese into the filament hole of your 3D printer.
Let's just say some things are meant for 3D printing and some things can be made using traditional means.
Yes. And the teleportation device, not under our current understanding of physics.
Current. Emphasis on current.
Yeah. I have an almost working one in my garage, but I'm not sharing you the plans for that. All right, so I think the first thing we really want to talk about is just the basics. Types of 3D printers. What are they?
Mm-hmm. Yes. So everyone, thanks for tuning in. The short and concise definition of 3D printing is getting a 3D model into the physical world. A 3D model that you designed yourself or that you buy online or you download, whatever, gets turned into a physical object. The technology. There are various types of 3D printing technology, but in general, 3D printing turns raw material, most commonly plastic, into extruded layers that get deposited one on top of each other from bottom to top, very thin layers that ultimately accumulate and create a 3D model. So Oliver, maybe we should talk about the different types of 3D printing technologies. There's many, but maybe we should stick to two.
Yes. Excellent. We'll probably stick to the most important two. You've got fused deposition modeling, which is, just the kind you see in sort of the common 3D printers found in makerspaces and schools. They squirt out molten plastic to build up a design. And then you've got stereolithography, where you fuse powders together by firing a laser at them. Mm-hmm. Now, stereolithography is relatively uncommon, but gaining in popularity. You usually won't have those at home. You would use a service. You'd send them their design, and then they will have an expensive printer that essentially has a bed of powder and then fires a laser at it to melt the stuff together. And then when they're done, they take away all the rest of the powder and they have a complete object. Builds it up layer by layer.
Mm-hmm.
Yeah,
exactly.
Now, the pipeline of 3D printing is a really important thing to go over. How you start from an idea and end up with a physical object. First thing is you design a 3D model. Leo's the expert here. What do we use for that?
Yes. So just a heads up, I teach 3D modeling at YoungWonks. Students who take these classes, they learn Blender and they also use Tinkercad. They have different purposes, but anyways, in YoungWonks we have an FDM printer, fused deposition modeling printer, and we use mainly one type of plastic, PLA plastic, and the PLA plastic is very commonly used, very commonly used. It is very easy to, it doesn't require much temperature. It does require heating, it does require temperature, but it is much more convenient, it's cheaper to use, it's more ecologically friendly as well. So that is the one we use at YoungWonks, and we use a Cartesian 3D printer. A Cartesian 3D printer is a kind of 3D printer which has the extruder moving in the 3 axes using rails. So Oliver, perhaps we should show the audience the picture of an FDM printer, a Cartesian printer.
Yeah, we actually have two printers right now. We've got one that's Cartesian. Hang on, let me look up our model.
By
Actually,
the way,
no.
guys, it's
Let me look
called
up a more common one. We have a really old one. Let me look. MakerBot.
Sure.
Sorry, I'm just bringing up an image right here.
No.
These are some examples of pretty common XYZ as in Cartesian printers. The part where plastic comes out moves across, backwards, forwards, up and down. We also have a DeltaBot printer, which is a little bit hard to explain, but it looks like this. Instead of moving in the XYZ directions, the extruder has 3 arms going to 3 pillars that all move just up and down. And through some complicated math, you can actually position the extruder wherever you want.
Mm-hmm.
Now, once you've got your 3D model, the next thing is you turn it into an STL file. On almost every 3D printing software, it's just file export. An STL file is sort of the lingua franca of 3D models for 3D printing. It's an interchange format you generally use to take your model out of the 3D modeling software.
Mm-hmm.
Next thing you do is run it through something called a slicer, which actually generates the code called Gcode that will control the exact motions of the 3D printer. Your slicer, there's a couple different slicers available. There's one called Cura, which is really good. There's also Slick 3R, and then there's a bunch of ones from manufacturers that are specific to individual printers.
Exactly, Oliver. Those layers I mentioned before are also a fundamental part of a slicer program, which is the middle part of the whole pipeline. It turns the model into the layers, and like Oliver said, it also Gcode also includes the way the extruder is going to move. It includes how much plastic will be used. It includes information such as what's the speed of the of the motors that are going to be spinning around, etc., etc. So it's all that information into a single file.
Yep. Gcode is also used to control other CNC type devices, like CNC mills, cutters, and all these things. But it's important to note, you can't take the Gcode for one device and use it on another device. They all kind of have their own dialects, and although it's roughly the same file format, Gcode is extremely specific to one model of printer. Even printers from the same manufacturer, you have to use different Gcode. So you have to make sure that your slicer software is set to your printer specifically. Now, let's get into some 3D printing tips. First one, hot tip, literally. Your 3D printer, you have to get your temperatures right. Look on the box for your filament. It'll tell you the range of temperatures that work. If it's too cold, the stuff doesn't melt. If it's too hot, sometimes the stuff doesn't stick, or the model gets squishy because it doesn't cool down. It's important to get your temperatures right. And more importantly, the bed for a 3D printer with the plate that it prints stuff on has to be heated, and the temperature to which you heat it sometimes determines whether stuff will stick or not.
Absolutely, Oliver. Temperature plays a big role. It's what makes 3D models 3D printable. Absolutely. And speaking, since you mentioned the printing bed, what are some tips, Oliver, that we should share with the audience to keep our models glued in the base so that they don't slide? A common mistake is when models get printed, especially in Cartesian printers in which the base is moving up and down, left and right. How can we make sure our models stay put?
The first thing is you want to have a model that has a large flat surface on the bottom. If you print like a sphere or something where it has a single point of contact with the bed, it's not going to stay there. Now, your slicer program can generate support material that'll help hold it in there, but generally it's better to actually design with 3D printing in mind, have a big flat surface. However, the real trick for getting things to stick is one that dates back to the RepRap home 3D printer movement, the people who made 3D printers cheap, which is this. You cover your bed in blue painter's tape, the papery kind, and then put glue stick on top of that. I have tried expensive bed adhesion materials specifically designed to make stuff stick to your 3D printer bed. You don't get results as good as just using blue painter's tape and purple stick glue.
Exactly. You told me that once, I remember. That's a pretty easy and cheap and affordable way of making it happen, to make it work. Fantastic. Let's see, Oliver. The next tip we have for you all is it is overhangs. So we must make sure that we have our overhangs taken into account. For example, if you're printing a statue, a bust of a person's head, that's the overhangs are gonna be happening around the chin area, underneath the jaw, underneath the nose. These are pieces of the model or the physical object that don't have anything underneath, nothing underneath. So nothing can be materialized out of thin air. Remember, layers get deposited from bottom to top. So support structures are the answer. But wouldn't you say, Oliver, that maybe rotating a model 90 degrees in the slicing program will surely avoid using unnecessary support structures?
Yes, you've got to think about how you're going to place your model, how you're going to rotate it so that support structures aren't necessary. For example, if you've got an overhang that's like this space underneath is not going to be supported. The thing's going to fall down. However, if you flip the model upside down, then you've got it coming up like that. That can be built up layer by layer more easily. There may still be support material sort of under here. But then there's something you have to consider, which is which surface you want to be kind of bad. So with 3D printing, if you've got an overhang and you're going to have, and it's generating support material under it, the support material often makes the surface kind of bad, like rough and this bit sticking out. You can remove some of that by sanding afterwards, but it's not, in general, a really good surface. So you have to decide which surface you want to look good and which surface you want to look bad, and then place your model accordingly.
That's a fantastic tip. For example, I have with me, it's a 3D model, 3D printed model of a dog. So anyways, I know it's hard to see, but I wouldn't print with the face facing the printing bed because I want the face of my sculpture to be as clean as possible. So it's better to print, to sacrifice, let's call it sacrifice. It's better to sacrifice a surface that you won't see, you won't be looking at so much. For example, the bottom of the statue, the bottom surface.
Yes. Oh, we have a question. What recommendations do you have for portable printers? That's a big trade-off because if something's portable, it's usually worse. I've heard that the PrinterBot Junior used to be good, but in general, you may want to stick to larger stationary printers if you can. Moving something around, especially something where there's a lot of calibration like a 3D printer, can tend to cause things to become skewed versus each other in the printer.
But are they, would you say portable 3D printers are cheaper? Is there, I would think so, right? Because they take up less structural
yeah, they do.
space.
Some of them do tend to be cheaper, but it's a trade-off. I don't know. The DeltaBot we have at YoungWonks was like a kit that cost $130, and it's a really good printer. So the whole cost thing is really tricky with 3D printers. Generally, just look at reviews more than you look at the price, because sometimes you get really cheap printers that are really good, and sometimes you get very expensive printers that have terrible software and don't work.
Another misconception would be about price versus quality and reliance would be those 3D printing pens. Have you seen them, Oliver? Those 3D printing pens that extrude as you write. It's fun. It's engaging, but don't expect it to work as well as a fully fledged 3D printer.
Yeah. Those things, they're not really 3D printers. They are useful for very, very specific things, which is if you want to do a kind of free-form 3D art and you're okay with learning the intricacies of how to use that. I'll say now, you can't just like make random shapes in the air with it and expect it to work. Like, gravity still exists. Hot filament is not stiff immediately as it comes out of your pen. However, there is one very specific use for those, which is you can use them like as a sort of glue pen to attach 3D prints to each other. But even then, there are a lot of stronger and better ways to do that.
Mm-hmm. That was a really fantastic question. Let's go on to the next tip. That would be um, oh yeah, ventilation. Ventilation. I was doing a bit of research and I found out that PLA plastic, the one that is made out of plants, is not as toxic as ABS. You guys are familiarized probably with Lego bricks. In case you don't know, the reason why Lego has so much quality in their pieces, in their bricks, is because they are made of hard, durable plastic called ABS. So, which brings me to my next point. If you are extruding ABS plastic at home, make sure your room is well ventilated. PLA, it's fine. You can keep your door open, keep the windows open, but with ABS, be very careful with those toxic fumes.
Yes. ABS is honestly a whole nother beast entirely, and if you're beginning with 3D printing, I don't recommend it, because first of all, with ABS, you have to have a heated enclosure, otherwise the stuff warps while you're printing it, unless it's a really, really small item. The bed temperature has to be hotter, the extrusion temperature has to be hotter, you get toxic fumes. You do get a stronger product, and the one other advantage of ABS I do really like is if you want like a mirror smooth surface of your print, you can take your ABS print and put it in like a box with a sponge soaked in acetone, and the vapors will melt the surface and make it smooth. It gets a really cool effect. On the other hand, acetone vapor is also extremely dangerous and extremely flammable. So that's something you'd want to do outside, probably with a bucket of water or a fire extinguisher available.
Absolutely, absolutely. Yeah, avoid any accidents, wear gloves. And another tip that has to do with protecting yourself is if you have to disassemble your printer, especially after you turn it off, make sure you you have gloves so that you don't, if you have to disassemble or replace the nozzle or the extruder, that thing is hot, really, really hot. Don't touch it with your bare hands.
Yes.
Wait for it to cool off. Have some gloves on.
And also, it's super tempting for some reason when you see a little bit of filament hanging off the nozzle that you know is going to mess up your print when it starts, to pull that off with your fingers. You'll burn yourself, because as you're doing that, the printer will start printing and then it'll, move the nozzle down. Just don't do it. Use tweezers. Use tweezers if you want to manipulate stuff that gets stuck on the nozzle, which is somewhat common.
What are some of the most common tools, Oliver, that a 3D printer enthusiast should have? Tweezers, obviously the 3D printer.
Metal spatula, like a thing for scraping prints off the bed.
Yeah, that's a good one.
Glue stick.
Digital calipers.
Yes, calipers very useful for designing stuff.
Yeah, digital calipers, guys, are like rules that use a tiny screen that actually tells you the decimals of. It gives you much more better these measurements, much better, up to, I don't know, 3. I don't know how it's much more. I don't know exactly how much are we talking about, but it's super accurate, much better than just a simple ruler.
Yeah,
classic ruler.
They're not just useful for your designs. You can also use them to sort of help calibrate your printer. Like if you tell the printer to do a demo 20 millimeter by 20 millimeter by 20 millimeter cube, you can measure that and check that it's actually the right dimensions, that there's not some kind of issue there. The other tool you should have is a sheet of paper. They're really useful for leveling your printer. This is less of an issue now because modern 3D printers have an automatic bed leveling functionality that measures at lots of points on the bed. But if you don't have that, you can pass a sheet of paper between the nozzle and the bed and ensure that it sort of can be pulled through but isn't too loose or too stiff. It's another of these old rep wrap tricks from the early days of home 3D printing.
All right. Let's talk about maintenance. Maintenance such as lubricating Cartesian printers. If you guys have seen a Cartesian printer, you will see that they use moving parts, and every moving part needs to be lubricated, especially parts that are made out of metal. So a bit of grease would do the trick, right? A bit of grease, maybe depends on how much you use the 3D printers, but perhaps once every 3 months, you should apply a little bit as in pistons or anything that is moving constantly.
Yeah, on our Delta bot, for instance, it actually comes with a tube of grease because the parts that move up and down are linear bearings, which have ball bearings inside them, and those need to be greased occasionally. Make sure you use the right kind of grease. The maintenance manual for your printer should tell you, do not just spray WD-40 and stuff randomly. That is not as good an idea as Family Guy would have you think. Now, we're gonna start taking questions in at youngwonks.com/podcast. The link is showing underneath us right now. So we'll just wait until, say, 6:25 for those.
In the meantime, Oliver, we could, before taking the questions from the audience and maybe sharing some resources for those who want to get started with 3D printing, I think we should go back to the tips and talk about infill. The infill percentage.
Ah, yes, I forgot about that one.
Yeah,
gotta get
too.
your infill right.
Yes. So, would you say, for those who don't know, a 3D model, a 3D printed model, such as this little statue of a dog, looks pretty complete on the outside, but on the inside, in an effort to save plastic and time, it's hollow. It's hollow, and instead of making a model that is 100% made out of plastic, the inside looks like a honeycomb structure. And honeycomb structures, not only are they hollow, but they maintain structural stability of the 3D printed model. So the question I brought up was the infill percentage. How much plastic should we really use on the inside? The rule of thumb is to use 25%, right?
Yeah, that's usually pretty good.
Standard.
Unless you need something really strong, you're not going to need more than that. There is one very interesting caveat to this. If you expect that for some reason you're going to try to deform your 3D print afterwards using a hot air gun or or something like that, which is something you can do. You can take a heat gun, point it at your 3D print, warm it up, and then kind of push on bits of it. If you expect you're going to do that, if it isn't a fully solid model, it doesn't really work. The thing will just kind of crumple.
Absolutely.
But other than that, don't use that much. Only use as much as you need to make it strong, which is actually usually a lot less than you think.
Mm-hmm. Mm-hmm.
Also, set your infill pattern to a pattern that changes as each layer goes up, so that the thing has some rigidity along multiple axes. It's a setting in Cura and other software as well.
Mm-hmm. That's a great advice. Let's see. Since so far we haven't gotten new questions, I think we can go ahead into resources, websites, products, even 3D printers we can recommend. And in the meantime, remember, guys, if you need a question, if you have a question, make sure to send us your question at youngwonks.com/podcast. So you mentioned Cura, right? Maybe we should start with Cura.
Yes.
It's free. It's optimized for I would say it is optimized for Ultimaker, which is the company that makes that software. So Cura is a great recommendation from both of us. It's free. It's a slicing program that ultimately it is used to create Gcode. That's step number 2 in the whole 3D printing pipeline. Cura is fantastic, and it allows the user to create unique 3D printing profiles, I think, right,
yes.
Oliver?
You can set one profile per printer, especially if you've got multiple printers. People have profiles for it for lots of different kinds of printers.
But what if you have a wrap printer? A printer that it may not have, maybe it was made by a company that doesn't offer a proprietary slicing program such as Cura. Would Cura be a good
yes.
slicing program for RepRap printers?
Yes. RepRap printers generally run the open source Marlin firmware, and Cura can generate Gcode for that. The actual format of the G-coded outputs will be right as long as you set it to Marlin. You're just going to have to tell Cura things like your bed size, your nozzle diameter, and some other physical parameters of the machine. But it can drive arbitrary Marlin firmware printers, which is really useful. Brings us to one last point. Make sure you print using an SD card. Don't print using a USB cable connected to the computer. The reason being, if your computer goes to sleep or shuts down or something, then the print will stop.
Oh, that would be awful.
Yeah, it's a lot of printers now let you print off an SD card where you put the G-code on an SD card and then it just pulls the file from there. It's usually a better option.
Right. Also, the manufacturer, if you need the printer settings so that you can create your own printer profile, the manufacturer, I'm sure they have that's figured out in their website. I'm sure they have their information because Cura is that well known.
Yes.
And widely used. Yeah.
Yes. Now, for 3D modeling, there's way too many software packages to name. OpenSCAD is good if you're a programmer and you want to do very mechanical type models. That's one where you write code that describes your model. If you're going to try to do like organic artsy stuff, you're going to use Maya or Blender. If you want to suffer, you're going to use FreeCAD. Don't use FreeCAD. I know it's free. I know it looks good, but it's extraordinarily difficult to use. If you are a student, you can actually get a free license for Autodesk Inventor or Fusion 360, which are also really good for sort of mechanical modeling.
Tinkercad is also another program that I would recommend. It is cloud. It's a cloud application. So you don't need to install it. You can use it on Chromebooks.
Yes, Tinkercad is really good. And it's intuitive to use, unlike a lot of other packages. And free. Oh, and the last one I want to mention is kind of a newcomer to the block. It's something called Onshape, which is also cloud-based, but it's closer to Inventor or SolidWorks in terms of how it works. It's a bit more advanced, but it's a proper, what they call parametric 3D design program. So you would generally use that for creating mechanical parts and things like that.
Yeah, which is better suited for people who are more interested in industrial design. People who want to build like planes or Xbox controllers or the shell, I don't know, more complicated stuff. More than just a statue, more than just a pencil holder.
Yeah. All right, so if there's no more questions in the chat, we'll wrap it up. But again, youngwonks.com/podcast. Come on, ask us some questions. 3D printing or making in general.
Mm-hmm. One more recommendation I have for the audience. If you are eager to try 3D printing, but you don't have a 3D printer, so you can get your very own. I would like to recommend Prusa.
Yes, they're the best
Prusa
ones.
Printers. If you don't want to spend money on a printer, maybe you don't have the room, maybe it's not a financial limitation, maybe it's not that you cannot buy one, it's that you don't have the space. There are 3D printing services out there. If your local, if your school has one, if a friend of yours has one, great. If you have a friend, etc. If you don't have any of those, I want to recommend a company called Shapeways. They 3D print for you, and they will ship it directly to your home.
Yep. Shapeways.com is a really great service. They can also print in some like unusual materials if you've got the money, like gold and brass and steel. Yeah. So it.
Oh, Oliver, I have a question for. I have a sort of question. The last one, I would say, and I get this from my students. How do I 3D print in colors? In various colors. For some reason, it's a very popular question, and I want to ask in behalf of them. I know the answer, but it's not all. First of all, not all the printers need it, right? You need multiple filaments connected at the same time, right? In the case for FDM printers.
Yeah, that's one way to do it. You can also get 3D printers that have 2 extruders and 2 sets of filament that can do multiple colors, but otherwise you're going to have to do it by either joining 2 filaments together or telling the printer to stop halfway through and changing the filament.
Or, yes, exactly. Or if your 3D printed object is made out of 2 pieces, well, you can have one piece made out of yellow filament, and then you can replace the filament and print the second piece with green filament, for example.
Yeah. All right. Now I'm just gonna check one last time. Can you 3D print cloth? No, not as yet.
I'm afraid not, but maybe
it's called sewing. Try it.
Maybe someday. We'll see.
All right. Well, yeah, thank you everyone for coming. We got some really great questions today. Remember to check out our next episode, 6 p.m. next Saturday.
Yep. Next Saturday at 6 p.m., right? Pacific time, right?
Yes. PST, yes, sorry. 6 p.m. next Saturday, PST, our next episode.